But Akumzi, who phoned in a short while ago, he didn't want the graph of tan theta, he wants the graph of tan 2 theta. And the 2 in front of the theta is simply going to change the period of the graph. So in other words, these repetitive bits of graph that we get, they're going to repeat themselves more often now. If the 2 were in front of the tan, so you've got tan theta, and I've drawn the graph for you. If it was 2 tan theta, then the period, the frequency of the graph would stay the same, but just the arms would be slightly steeper. Let's have a look. If I now try and draw the graph of y equals 2 tan theta on the same set of axes, we're going to try and draw the graph of y equals 2 tan theta. Not tan 2 theta, but y equals 2 tan theta. If we go back to our calculator and we type in tan of 45, we get 1. But because there's a 2 in front, we need to multiply by 2. Or we can go 2 times tan 45 equals. And what we see is we get 2. In fact, what happens is we simply get all the answers we got previously, but now they are multiplied by 2. So we see that the curve is exactly the same curve, just slightly steeper. That's all it is. Same curve, but just slightly steeper. So here, steeper curve. Steeper and steeper. Why is that? Because all the values that we obtain, we multiply by 2. So in line with that theta, we're not getting that value, we're now getting that value multiplied by 2. So that value jumps up and gives us a higher amount. That which I've drawn in yellow is the graph of y equals 2 tan theta, where the 2 is in front. What is the period of this graph? It's still 180. Because the graph repeats itself after every 180 degrees. So the period of the graph is 180 degrees. By the way, you should note that the tan graph does not have amplitude. The tan graph is not a wave, and so the tan graph does not have amplitude. Only the sine and the cos graph have amplitude. Let's go and look at y equals tan 2 theta now. If we look at y equals tan 2 theta, we get, and we're going to draw it. The question was sketch it from minus 90 to 180 degrees. Now remember, we're drawing y equals tan 2 theta. So when you put the values into your calculator, you are very careful to go tan. Then I need the 2 theta. So tan, open the bracket, because the angle is a complex angle, so we need to do it in a bracket. 2 times, and then whichever theta we like, let's say we say 0, close the bracket. There you have it. I hope you can see this. Tan, open bracket, 2 times 0, close bracket, equals. It gives me 0. So in line with 0, the point that I get is in fact still 0. If I now take 45 and I plot the point for 45, I'm going to go tan, open bracket, 2 times 45, close bracket, equals. I get an error in line with 45, which means I now have an asymptote in line in 45. If I type 90 in, I'm going to go tan, open the bracket, 2 times 90, close the bracket, equals. I get 0. If I type 135 in, you'll get an error, and if you type 180 in, you'll get 0. Type in minus 45, you'll get an error, and type in minus 90, you will get 0. So previously, when we looked at the previous graphs, when we looked at the graph of y equals tan theta, we saw that the asymptote was in line with 90. Now the 2 theta has caused the asymptote to be in line with 45, because if this angle is 90 degrees, then tan of 90 is error, is undefined. So this error that we get on the calculator will occur every time the angle is 90 degrees. Every time the angle is 90 degrees, we're going to get an error. So if we've got 2 theta as part of the angle, then when we're working out tan, we get error if this is 90. What must theta be for this to be 90? Theta would have to be 45. And that's why your error, or your undefined, now occurs when theta is 45. What do you think is going to happen? Same thing. If you plot points, you're going to observe that the curve is a smooth curve that away and back down. Same thing going up to that asymptote and down, following the pattern that it is. So in the exam, what is my advice to you in terms of sketching this graph? In the exam, when you're sketching this graph, I would say it is really important to make sure that you have the asymptotes in place first, because then it is really simple. The shape of the graph never changes. It's that kind of little bit of a curve that has what we call a point of inflection in it, but the shape of the graph stays the same, and that shape occurs between the asymptotes. What are graphs about? Sketching graphs, they're about plotting points. And you should attack the question in the exam in the same way that I did right here. Okay, Akumzi, and the rest of you watching, I hope that I made the graph of tan theta a little bit clearer for you. And so after the break, we're going to have Mags back with us with a question.
Keep this frequency clear.